Now that you have a Git repository in place with some commits, the goal in this video is to get all of that code up on GitHub. That's going to allow you to back up your code, collaborate with others, and take advantage of all of the other awesome features that GitHub has to offer. So we have to go through a few steps. First up, we have to create a GitHub account. Second up, we have to figure out how we're going to securely communicate with GitHub from the command line. Then we'll actually be able to get our code up on the GitHub website. Step one over inside of the browser is going to be to create a new account or sign into your existing one. You can head over to github.com to get that done. If you do have an existing one, you can continue to use it. If you don't have one, you are going to need to sign up. Either way, let's all go ahead and get into our GitHub accounts, whether you're signing up for the first time or logging in to an existing one. So take a moment to pause the video if you need to. From here on out, I am going to assume you are logged into your GitHub account. The next thing that we're going to do is create a new repository. Your page isn't going to look the same as mine, but you should still see a little plus button up here where we can make a new repository. It's also in other places throughout the interface. And when we go to this page, it is going to ask us for a little information. So this is going to be a specific repository for this one project. If I'm pushing up 5 different projects, I would create 5 different repositories. This one is specifically for the Expensify application. I'm going to call mine React Course 2 Expensify app. You can call yours whatever you like. You could call it Expensify app. You could toss your name in there. The choice really is yours. Then we have the description, just an optional description describing what this project is. We can leave that empty. Then we have the option to go either public or private. Now, unless you're on the paid plan, you're going to have to go with a public repository. This means that others can view your code, though they can't directly change your version of the code. I'm going to be going with a private repository only to prevent some of the students who track my GitHub from seeing that a new course is about to come out. So you can go ahead and use public. I'm going to use private. The steps are exactly the same. Down below, we have the option to initialize it with some files. We don't want any of that. We have all of the files locally on our machine. So we're going to go ahead and just click that Create Repository button. Now at this point, GitHub is going to show you a bunch of commands. There are commands depending on what you have. So maybe you don't have a repository and you want to create a new one. Maybe you have an existing one you're just trying to push up. Now at this point, we would run commands like these two right here, but we actually can't because we don't have a secure way to communicate between our machine and the GitHub servers. To get that done, we're going to be setting up SSH, which stands for Secure Shell. This is a secure way for 2 machines to communicate. And in order to actually make it secure, we have to set up what are known as SSH keys. Now, if you already have SSH keys on your machine, you can continue to use the existing ones you have in place. If you don't have any, or you're not sure if you do or not, there is a simple command we can run to find out. So let's switch over to the terminal and get started. Now, if you're on Windows, this is the point in time where you have to use git bash. The commands that we're going to use to check for SSH keys and create new ones are not going to be available on the regular Windows command prompt. So make sure to switch over to git bash. If you're on OS X or Linux, you can continue to use the regular terminal, which is exactly what I'm going to do here on my Mac. Now, the first command that we're going to run is going to check for existing keys. We're going to be using the ls command, which is going to list out all of the files in a specific folder. We're going to use the A flag to make sure to show all of the hidden files as well. And the folder that we're looking for is in the user directory. It's called .ssh. So I'm going to use tilde, which is the shortcut for the user directory, /.ssh. Now this command is going to do one of a few things. Your output might not be the same as mine, and that's okay. So when I run this, what do I get? I get an empty directory. And this means that I do not have SSH keys and I need to create some. You might also have gotten an error saying that the SSH folder doesn't even exist. That is typical for Windows users. If you're seeing that, that just means that you also need to create some keys. Last up, you might have keys showing up. You might have ID_RSA and ID_RSA.pub. If you do have those in place, that means you have existing keys and you actually don't need to go through the process of creating new ones. You can just use those, which is what we'll be doing in a few minutes. At this point, we are going to go ahead and create a new set of SSH keys. There are 2 files associated with this. There is a private file that we keep on our machine, and there is a public one that we're going to give out to third-party services like GitHub. I'm going to clear the terminal output and we're going to create our SSH key pair. All the commands that we're running come from the GitHub setup guide, and I do want to show you where that lives in case things change over time or you're not quite sure exactly what's going on. If we just Google connecting to GitHub with SSH, this is going to bring us over to their very popular article. If we click this, it's going to show us the various steps we need to take. The first one is about SSH and checking for existing keys, and we've already done that. The one we're going to move on to now is actually generating the SSH keys, so we can click this. And this shows a different set of directions depending on your operating system. So if you are confused about exactly what command you should be running or it's not working as expected, I recommend coming over to this article, picking your operating system, and viewing the instructions down below. Now, these steps, the ones that we're going to be taking right here, they are the same for all operating systems, except on Windows, you obviously need to use git bash. So let's go ahead and kick things off by generating the new SSH key. The command we're going to be running is SSH-key gen. This allows us to generate a new set of keys, and there are a few arguments that we have to provide in order for this to work correctly. First up, we have to provide the T flag. This lets us specify the type we're trying to create, and there are a lot of different types of keys we could create. The one that we're going to be using is the popular RSA. So this is what we're going to be using to securely communicate with GitHub. Next up, we have to pick the size. Bigger is better. The B flag, which stands for bits, is going to get set equal to 4096. The bigger the key, the harder it is to crack. This is the size recommended by most services, including GitHub. Next up, we need the capital C. This is short for comment, and this allows us to provide right here our email address. And this is just going to be associated with that key pair, so we know exactly what we meant to do with that SSH key. In this case, all I ask you to do is just toss your email address in here. And once you have all of these arguments in place, take a quick moment to just double check them. Once everything does look correct, we can go ahead and actually run the command. Now, when we run the command, it's not just going to go through the process and finish. It's going to ask us for a little information. First up, it's going to ask us exactly what we would like to call the file. I always recommend sticking with the default ID_RSA. To stick with the default, I just hit enter. Next up, it's asking us for a passphrase. This is something that we do not want to do, so I'm going to hit enter for this to say no passphrase. Then it asks me to confirm. Once again, just enter for no passphrase. Then and only then does it actually generate the key. Right here, we can see exactly where things were saved. We have our private key and our public key files both saved in the SSH folder. And now we can go ahead and actually use those in a meaningful way. We're going to go ahead and set them up with GitHub so our machine can communicate with GitHub based off of those files. Now, if we clear the output again and run that previous command, ls with A, and we look into the users.ssh folder, we should see some different output. Here I am getting the ID_RSA file, which is my private key file, and the ID_RSA.pub file, which is the public key file. This is the one that we're going to be giving out to other services. This is the one that you never want to give out. Treat this like a password. We don't want someone to be able to access that because then they'd basically be able to steal our identity. They could trick another machine into thinking that they were us. The next command we're going to run is going to make sure that when we try to communicate with another service like GitHub, it actually knows which SSH keys to use. This is going to require us to use a tool called SSH agent, and the first thing we need to do is make sure it's running, and we're going to run this kind of quirky command to get that done. So bear with me for the moment. It is eval. Then inside of quotes, we're going to type some stuff. It is a $, an opening and closing parentheses, and inside of the parentheses, we are going to type SSH-agent --s. So this is going to essentially check if SSH agent is running. If it is running, it's going to let us know that. If it's not running, it is going to actually start things up. I'm going to run the command. Right here, you can see it is running, and I am getting the process ID. So once you've run that command, the last thing to do is to use SSH-add to actually add the new key. Now, we have to provide the path to the private key file. That would be the user directory. In there, the .ssh folder, / in there, ID_RSA. We don't want the pub file, we want the private file. Once we run this, we can see the identity has been added, and now we're ready to actually take the public key file and give that to third-party services like GitHub. To get this done, the first thing I'm going to do is clear the terminal output, and this command is going to be the most unfriendly cross-OS command we're going to run in the entire course. It's different for all operating systems, and it's a real pain in the butt. So the goal is to just take the contents of that idrsa.pub file and copy it to the clipboard. Now, yes, you can open it up in a text editor if you want, but if we do head over to the documentation and we go back a page to the list of guides, we can actually view the guide for copying things to the clipboard. Under this one, we have adding a new SSH key to your GitHub account. And right here, we have the command we can run on Mac to copy that file to the clipboard. We have the command we can run for Windows to copy that to the clipboard. And we have the command we can run on Linux to copy things to the clipboard. So feel free to go through the guide for your operating system. You should just need to click it up here and actually run the command. I'm going to go through this process for my Mac. I'm going to take the command, copy it, head over to the terminal, run it. This is going to take the contents of that pub file and copy it to the clipboard. Once it is copied to the clipboard, we have to give it to GitHub, and we do that by actually visiting our GitHub profile page. We're going to go up here to settings. Then we have to go to SSH and GPG keys, and in here, we're going to be adding a new SSH key. Now it asks for a title. This is just a way to remember exactly which machine you're working with. So I'm going to say work Mac. Then down below, we have to paste in what we copied from the clipboard. And if you actually do that, it should be a whole bunch of mumbo jumbo, starting with SSH-RSA and ending with your email address, the one you provided in the comment when creating the key. If you are seeing this, great. If not, feel free to open up a question in the Q&A about actually copying that text. I'm going to go ahead and add the new SSH key. And at this point, we're actually ready to securely communicate with GitHub from our local machine. Right here, we can see the key was added, but it was never used. So let's go ahead and run a test command to make sure that everything was set up correctly. Once again, we're going to head back into the terminal. I'm going to clear the terminal output, and we're going to run a single command. It is going to be SSH with the T flag, and this is going to disable some features we're not trying to use. And then it's git@github.com. So all this is going to do is try to make a very basic SSH connection to the GitHub servers. It's either going to work if the key was set up correctly or fail if something didn't get set up correctly. So if I run this, it's going to take a second or two. It's then going to ask me if I actually do want to connect to that IP address associated with GitHub, and I have to type yes. Then it is actually going to try to make the connection. And right here, you can see my username shows up. So I'm getting a message, "Hi, Andrew J. Mead. You've successfully authenticated, but GitHub does not provide shell access." So this is exactly what you should be seeing. If you are seeing this message, that means your keys were set up and you have a secure connection to GitHub. If you're not seeing this message, that means your keys were not set up and something went wrong, which means you're going to want to go back through those steps or just open up a question in the Q&A. This is by far one of the trickier videos, because there are a lot of things that can go wrong. There's a lot of new tools and things that we only do one time. And now that we do have everything set up though, we can actually push our code up to GitHub. So once again, I am going to head back over to the repository page. If we go to github.com, we should be able to find it in our repositories list, and it should be near the top. Now here we had those set of instructions. Down below, we have some instructions showing up. This is for pushing an existing repository. This is for creating and pushing a new one. We're going to go through these steps, but I want to show you how they work. So we're not just going to copy and paste that. Instead, up above, we're going to grab the SSH URL, not the HTTPS one. I'm going to copy this using their handy little button, and we're going to take this and run a command from Git to let Git know that this is where our remote code should live. To do that, from the terminal, we're going to use git remote add. This lets us provide a remote name and a remote URL. Now your default name should be origin. This is for your main repository, and the value needs to be the URL that you just copied. So I'm going to paste that in. Then we can go ahead and hit enter, and now our local Git repository knows, at least, that this external remote repository exists. If we run git remote, we should be able to see that origin is showing up, which is great. And if I run git remote with the v flag to view the verbose output, we should be able to see the actual URLs. Here we now have 2 records. We have one for fetching and one for pushing. And in almost all cases, including this one, the URL is going to be exactly the same. So now that we have the association set up, the only thing we have to do is actually push the code up. And we're going to do that using the git push command. Now, git push does take a few arguments. The first argument is the U flag. This creates the association between our local code and the upstream GitHub repository. So we only have to use the U flag one time right now. We'll never need to use it again. The next 2 things we're going to type is the remote and the branch. So the remote we just set up was called origin, and by default, the branch that we're going to be working with is master, and we're only ever going to be working with the master branch in this course. So when we run this command, it is going to take all of the local commits to our master branch, which are the 2 we have set up, and it is going to push them up to GitHub. I'm going to run the command. You can see it's now actually communicating with the servers, and in the end of the day, you should see some output like this. We have a new branch, we have a remote branch for the local master one, and then we have a little message. Branch master set up to track the remote branch master from origin. And this is all correct. If you are seeing this, you should actually be able to refresh the browser page where your repository lives, and you should now see your actual code. So right here, we have all of the files that make up our project. We can click into the individual files to view those. We can pop into the directories, and there are a ton of other useful features too, like being able to set up projects, wiki documentation, tracking issues, and more. If we do go over to the commits area, this is where we can view all the commits that make up our project. Right here, we have the initial commit, and we have our commit to remove the dummy expense data. If I click one of these, we can take a deep dive into exactly what changed. Here we can see that we had all of this code before, it was deleted, and now that does not exist in the latest version. So GitHub is a fantastic place to store and track your code. We're going to be pushing all of our code changes up to it. That is it for this one. In the next one, we're going to start diving into our production Webpack build. Let's go ahead and jump into that.